Welcome friends to my YouTube channel. On yesterday's lecture, I have told about the moment of inertia of a elliptic disk about any of its principal axis. Okay, now in today's lecture, I shall going to discuss the moment of inertia of a triangular lamina. Now the figure is triangular lamina. So about one side as axis. So just draw the figure. This is A, B, C, D. This height is say H. So about this axis, so we take a strip at a distance x. Okay. If we are going to find out the moment of inertia about BC, so we take a strip at a distance x from BC. Okay. So if this is x and the total height is h, this is h minus x. Okay. So what will be the area of the strip? So we consider the strip at a distance x. Say the width is dx. Okay, and this length is y. Say so y into dx. This is the area of the strip. Okay, the height AD is h. Okay, and say BC, this is equals to A. So we take the strip at a distance x from BC. So if total is h and this is x, this is h minus x. So what will be the area of the strip? Area of the strip is length into breadth. What is length? Length into width. So this into this. So since this is x, so this width is dx and this you can call y. So this is the y dx. Okay. So if rho is the mass per unit area, so what will be the mass of the strip? Mass of strip. Rho is the mass per unit area, so my area will be y dx. Fine. Now what will be the moment of inertia of the strip about BC? So if we call it di, so this will be simple, rho y dx into distance square. That means strip and the arm x is this, that x square. So this is the moment of inertia of the elementary strip of width dx and length y. Okay, fine. Now rho y dx into x square. Okay, we find di, this is equals to rho into y into dx into x square. Okay, now just see this small triangle and this entire triangle. Okay, you give it a name, say EF. Now you can write from triangle ABC and triangle AEF, that is this thing by total, this is equal to this by total. Okay, this is what this is h minus x by this is h minus x and the total is h. Okay, and this is y and this is a. You can write it. Okay, this small thing by total and this small thing by total from triangle ABC and AEF. Okay, so what will be my y? A by h into h minus x. So we have to substitute this value of y. So what will be my di? Rho x square a by h into h minus x into dx. Now, what should be the moment of inertia of the entire triangular lamina about BC? So this is A. Oh, sorry. Uh, this is vertex. This is say 0, and this height is h. So we have to integrate this above from 0 to h. Okay. So we have to integrate this within 0 to h because the entire height is h. We have to find out the moment of inertia about BC. So we have to integrate this expression within 0 to h. So rho a by h minus x into x square dx. So this is constant, so we can take it out, and this is h. If we do x square dx, that means x cube by 3, and x cube dx, that means x to the power 4 by 4. The limit will be 0 to h. Fine. So let us calculate this. Okay. So what will be my I? This is simply rho a by h. This is simply h to the power 4 by 3 minus h to the power 4 by 4. This is rho a by h. This is 12 h to the power 4. That means 1/12 rho a h cube. Okay. Now what will be the area of the triangle? Again, if we draw it, A, B, C, this we take A, this is H. So the area is simply half A, H. Okay, the area of the triangle is this. So just write it 1, 2, 1, 6. This is A rho H into H square. This is the area, and if we multiply it by rho, this is the total mass, because rho is mass per unit area, so this represents the total mass. So m h square by 6. M, what we can write? A h rho, mass of the triangle. Mass of triangle. So this is the moment of inertia of the triangular lamina about any of its sides. That means we take B. And since this is vertex 0, 0, and this height is h. Okay, so mh squared by 6. H is the distance between the vertex and the arm. Okay, so this is about any of its side. Now another axis, that is about an axis passing through the center of gravity and parallel to one side. Say this is DEF. Okay, about an axis passing through the center of gravity and parallel to one side. About an axis passing through center of gravity and parallel to one side. So what we know from parallel axis theorem? Moment of inertia about this axis, this is equal to moment of inertia about this axis plus mass into distance square. Okay, so here we can write the moment of inertia about BC. Okay, moment of inertia about BC, this is equals to moment of inertia about this, say DF, plus mass into distance square, mass into distance square. Now we have, if we consider the total height is h, now we know this is the centroid, that means this is 2:1 ratio. Fine. So say G. Okay, so if AG is h and E is the centroid, that means AE, this is equals to 2h by 3, and EG, this equals to h by 3. That we all know from the property of triangle, the centroid E. So this is obviously 2h by 3, and this is h by 3. Okay, how we can calculate the centroid? We all know the formula of centroid is simply na plus mb by m plus n. For a triangle, this is the formula of centroid. Okay, now so if total is h, this is 2h by 3 and this is h by 3, that means this distance is h by 3. Fine. Now we have previously calculated that moment of inertia about BC is mh square by 6. So we have to find out about this axis IDF, and the mass is m, and what is distance square? h by 3 whole square. So this is simply IDF plus mh square by 9. So what will be my IDF? mh square by 6 minus mh square by 9. Okay, this is 18, 3 minus 2, mh square. So the result is mh square by 18. Okay, so this is the moment of inertia about an axis passing through the center and parallel to one side. Simple application. Okay, so this is what about the triangular lamina. So in our today's lecture, I shall discuss about the moment of inertia of a triangular lamina. Now on my next lecture, I shall going to discuss the moment of inertia for other objects like spherical shell spheres, that we will going to discuss in the next lecture. And if you don't subscribe my channel, then kindly subscribe it to get latest videos on physics. And one thing to all of you, happy Holi. Okay, thank you.